Hello dear friends, welcome to my YouTube channel. This is Giancoli physics for scientists and engineers. So the topic name is RC circuit. So let me define. RC means the circuit that contains resistors and the capacitor in series. So they are have many applications, just like winds, cars, wiper. They are circuit that is used to control the speed of cars, wiper, traffic signal, time of wiper signals, and they are used in the camera flash. These circuits, resistor and capacitors. Okay, I will explain in the detail. Okay, so the simple circuit that has in which the resistor R and capacitors here connected in series is RC circuit, and in this circuit we connect a battery with the battery. So this is the when we connect with the battery. Okay, now this is the circuit for charging. So initially the capacitors has no charge. Okay, so when we connect with the battery, so the charge is developed on this capacitor. So initially when the switch is open, so no current flows, there is no charge on the capacitor. Suppose we close this switch. When we close this switch S, so that the current start flowing through this because the potential difference between battery EMF mean the battery, for example, has 220 volt and capacitor has 0 volt. So that there is a potential difference between the capacitor and the battery. So the current charges start flowing from high potential to low potential. Because there is a high potential, so there is a low potential. So the battery supplies charge to the capacitor. So the process of charging starts. Okay, so charge is not developed immediately. Okay, it will gradually develop on this capacitor. Okay, so when the charge is developed on this capacitor, this stores positive plate stores positive charge and negative stores negative charge. Okay, so the potential drop across this resistor is VR, because we know that there is a potential that must be drop across this resistor. Okay, so that according to KVL, so if we apply KVL, so the battery supplies EMF plus E, because we know that we are moving from positive to negative to positive terminal. When we move from negative to positive, so the potential is plus E. So the battery supplies potential plus E, and the capacitor stores potential. So the potential stored on the capacitor is minus Vc, and the potential drop by the resistor is VR, so which is equal to 0. We know that according to KVL, the sum of all potential changes in a circuit, sum of potential change must be equal to 0. So that there are three potential changes, E minus Vc minus R is equal to 0. So Vc is, we know that capacitor voltage is V is equal to Q by C, and VR is equal, according to Ohm's law, V is equal to IR. So I is equal to dq over dt. So we have to write dq over dt, which is equal to 0. Okay, so if we multiply with the C on both sides, multiplying by C, so we get EC minus Q minus dq over dt into RC, which is equal to 0. So we further simplify this circuit. So we have EC minus Q, which is equal to dq over dt into RC. Okay, now we separate the variable, separation of variable. So if we separate the variable, so we have 1 over RC into dt, which is equal to 1 over EC minus Q into dq. Okay, so we rearrange this equation. So 1 over EC minus Q, which is equal to dq, which is equal to 1 over RC into dt. Now we integrate. So charge is 0 to Q, because you know the initial charge is 0 and final charge is Q, and the time is 0 to t. So v 0 to t. Okay, now we integrate this one. On the left side, this is simply log function of logarithm. So we can write log of EC minus Q, because we know that this is negative Q, so we can write minus Q, because if we derivative of this EC minus Q is minus 1. So if we write minus 1 on the upper and the lower side, so that this minus 1 is used by this logarithm. So log EC minus Q is equal to, minus will be introduced on the outside the bracket. So minus log of EC minus Q is equal to 1 over RC into T. Okay, because so 0 to T, so the upper limit and lower limit is 0 to Q. So we write log of so this minus can be shifted to the other side, it's better, minus 1 over RC into T minus 0. On this side we have log of EC minus Q. This is upper limit is Q. Now we use minus formula minus and then log of EC minus 0 which is equal to this. Now we can write log of EC minus Q minus the log of EC which is equal to minus T over RC. Okay, now we simply log rule, we use log rule. Log of A minus B is equal to log of A over B which is equal to minus T over RC. So in order to remove this logarithm, we use exponential log of EC minus Q over EC which is equal to exponential minus T over RC. So 1 minute, exponential minus T over RC, exponential minus T over RC. Okay, this exponential and log will be cancelled, so EC minus Q is equal to EC into E power minus T over RC. So the Q, we can find Q which is equal to EC minus E power minus EC E power minus T over RC. So simply if we took EC common, so 1 minus E power minus T over RC. So this is Q. So this is a Q. So this term is Q maximum. So is equal to Q maximum which is equal to 1 minus E minus T over RC. So simply if time is 0, so we know that if time is 0, so if E power 0 becomes 1, so this term 1 minus 1 becomes 0. 1 minus 1 becomes 0. So initially when time is 0, the charge Q is also 0. The charge is 0. When the T is infinity, so the Q is also maximum. So this is charge. So we can find potential by using the equation formula Q is equal to CV. So we can use from the Q we can find V by using the formula Q is equal to CV. So we can write CV is equal to CV maximum which is equal to 1 minus E power minus T over RC. So the C will be cancelled. So the V is equal to V maximum. V is equal to V maximum which is equal to 1 minus E power minus T over RC. So this is the potential that is developed. The potential is that is developed which is equal to E power minus 1 over RC. Similarly, we can find the current I. V is equal to IR. So we can also find I by taking derivative of this equation Q. So the Q dq over dt which is equal to, if we took the derivative of this term, so we have value that is equal to so we took this derivative of this term EC term. Okay, so the derivative of this term, so we get I is equal to dq over dt which is equal to EC into 1 minus exponential derivative. This exponential term derivative 1 is 0. We know that the derivative of 1 is 0, so we have exponential term derivative is minus E over T over RC and minus 1 over RC. So this C will be cancelled, this and E over R, so 0 minus E power minus T over RC. Okay, now so I is equal to, so E over R is I maximum, so I is equal to I maximum into E power minus T over RC. So this negative, it will be cancelled with this negative, so we are left with the plus. Okay, so the current has the same form. So all these equations, the formula for current, the formula for potential, these all shows that the so we can say that the potential, this is the graph for the potential, that is VC capacitor, potential developed on the capacitor. So the graph says that the potential increases gradually on the capacitor. Okay, now one more thing, the term now we define the term time constant. The time constant T is defined as the product of resistance and capacitor RC. The product of resistor R and capacitor C is called time constant tau. So mean this is the time during which the capacitor stores the 63% of the charge. The 63% of the charge is stored on a capacitor is called the one time constant, 1 tau. 1 tau is equal to 1 RC. So 63% 63% of potential is developed, or 63% of the total charge is developed on the capacitor is 1 RC. So RC is equal to 0.63 times E. So we can say that the current gradually decreases, because we know that when in the starting the capacitor stores max